If you've ever managed thousands of records in a single spreadsheet, you know the dread of a single wrong keystroke corrupting everything. Upgrading to a programmatic data engine means leaving that manual chaos behind. Before you write a single line of code, you have to choose a blueprint. Every data engineer faces a massive architectural decision. Do you use a highly structured relational SQL database or a flexible, non-relational NoSQL setup? This table lays out the core philosophies of both. SQL relies on strict asset guarantees for transactions and scales vertically, meaning you buy bigger, more expensive servers. NoSQL operates on base theorems, prioritizing speed and scaling horizontally by linking together cheaper commodity servers. Choosing the correct foundation early on ensures that when your application scales to handle millions of requests, you don't face massive data corruption or total system failures. Once you have your blueprint, you have to talk to the server. But humans and database engines don't read code the same way. We read top to bottom. The machine reads in a strict logical sequence. Looking at this execution order, the engine first uses from to locate the table, then where filters the raw rows. Select is processed last. Because select happens last, you cannot use an alias created there in your where condition. The query will fail. You also have to know exactly what you are filtering. The where gate evaluates individual raw rows as they come in. But if you sort those rows into distinct groups, you need an entirely separate gate, the having clause, to filter those aggregated buckets. Internalizing this specific sequence preempts the machine's logic, turning a list of commands into a predictable, error-free workflow that saves hours of debugging. In a real enterprise ecosystem, data doesn't live in one massive table. It's fragmented across different tables to prevent duplication. To yield insights, you have to stitch these isolated pieces together. Combining tables executes set theory. An intersection represents an inner join, returning perfectly matched rows. A union is a full outer join. In business, finding active players who also spend money means querying that exact intersection using an inner join. To find the void, what is entirely missing, you construct an anti-join. By combining a left join to attach records with a strict where is null filter, you isolate the exact users who, for example, have absolutely no purchase history. Thinking in mathematical sets turns chaotic data merging into pure, predictable logic. You never guess the syntax when you know exactly which part of the Venn diagram you need. Writing these queries requires physical consideration of your hardware. If you run a full outer join on a massive dataset, the server must hold both entire tables in its memory at once. Execute this carelessly, and the server crashes. Joining large tables without indexing checks every row combination, causing an exponential explosion of operations. The fix is joining on primary and foreign keys. These pre-sorted keys drop your search time drastically, turning 10-minute queries into 10 milliseconds. Writing code that respects the physical limitations of the hardware is known as computational empathy. It is the dividing line between a junior coder and a true data architect. Advanced engineering centers on server-side transformations, cleaning and calculating raw records before they ever touch a reporting dashboard. Look at this case statement. It evaluates a raw age column and automatically categorizes users into cohorts like senior or adult. This technique, called data binning, transforms continuous numbers into dashboard-ready categories instantly. You can also future-proof your filters. By nesting a subquery inside your where clause to calculate the exact average salary, the main query adapts automatically. As the company's average pay shifts over time, your code updates without manual intervention. For financial reporting, you can force the engine to do the heavy lifting by adding the with rollup modifier. The database automatically generates rows containing accurate subtotals and an overall grand total. By utilizing the server for these intense calculations, you completely eliminate the need to manually build pivot tables in a spreadsheet. The result is a secure, automated, and highly efficient enterprise pipeline. We started by choosing between strict and flexible architectures, translated overlapping data tables through mathematical set theory, and finally pushed our database engine to automate complex financial analytics. You've moved past manually viewing grids on a screen. You are now applying programmatic logic to organize and manipulate information at an enterprise scale. Mastering the syntax provides the tools.
The primary objective is to architect, optimize, and govern the entire data ecosystem.